On the morning of the 11th of June 2026, forecasters at the National Oceanic and Atmospheric Administration made it official. El Niño is here. For the first time in about 2 years, the warm phase of the Pacific has taken hold, and the agency issued what it calls an El Niño advisory. That word, advisory, just means the conditions are present now and expected to stay. If you like to follow these Earth reports as they come, you are welcome to subscribe, and then we will get straight into it. What makes this one worth a closer look is its strength. The ocean along the equator is running warmer than it should for this time of year, near record warmth for the season, and the forecast leans toward a strong event by fall, with a real chance it ranks among the largest ever measured. People have already started calling it a super El Niño. This report walks through how it formed, why it counts as unusual, and what it means for America in the months ahead. We will follow it in plain order, from the first warm signs in the Pacific to the winter now taking shape. The news did not arrive with sirens. It arrived on a Thursday morning in a routine update that the Climate Prediction Center posts on the second Thursday of every month. On the 11th of June, 2026, that update carried one line that forecasters had been watching for: El Niño conditions are present. With those words, the National Oceanic and Atmospheric Administration moved its alert system to what it calls an El Niño advisory. That term is worth slowing down on because it sounds heavier than it is. An advisory, in this case, is simply a status. It means two things at once. The warm pattern is here now, measured and confirmed, and it is expected to stay for a while. It is not a warning of danger today. It is a notice that a large, slow shift in the Pacific Ocean has crossed a line, and that the shift will shape the seasons ahead. The reason a single sentence draws attention is the size of the thing behind it. El Niño is not a storm you can point to on a map. It is a change in the temperature of a stretch of ocean near the equator, thousands of miles wide. When that water warms past a certain point and the air above it responds, the effects ripple outward for months, reaching weather far from the Pacific itself. So the forecasters do not declare it lightly, and they do not declare it early. They wait until the ocean and the sky both agree. This particular announcement carried a little extra weight for two reasons. The first is timing. The Pacific had been quiet in this respect for about 2 years, and an El Niño had not been in place across that whole stretch. The second is strength. The early readings were not borderline. The ocean was already running warm for the calendar, and the forecast leaned toward a strong event by the cold months, with a real chance it would rank among the larger ones on record. It helps to picture how that morning actually unfolded inside the agency. Scientists at the Climate Prediction Center work with forecasters at a research institute that focuses on climate, and together they review the same set of numbers each month. They look at ocean temperatures gathered by satellites, by buoys floating in the tropical Pacific, and by ships. They look at the winds and the pressure in the air above that water. When enough of those signals line up, and when the models say the pattern should hold, they issue the advisory. There is no drama in the room. There is a checklist, and the checklist had been met. The director of the National Weather Service put the spirit of it simply when the advisory went out. Every El Niño, he said, is unique, with its own imprint on the weather. That single idea will return through this whole report because it is the honest frame for everything that follows. The pattern tilts the odds. It does not hand out guarantees. Still, the declaration matters because of what it unlocks. Once El Niño is on the board, the seasonal outlooks change shape. Forecasters can lean on decades of past events to sketch what tends to happen next. They can tell farmers, water managers, and emergency planners that certain risks have shifted, some up and some down. They can say, with more confidence than usual, where the storm track is likely to favour through the winter and where it may turn dry. The advisory is the starting gun for that planning. For most people, the 11th of June felt like an ordinary day. No rain fell because of this. No temperature jumped overnight. That gap between the announcement and any felt change is itself a feature of El Niño, not a flaw in the forecast. The ocean leads and the weather follows later, mostly in winter. We will come back to that delay because it explains why a pattern can be both real now and quiet now at the same time. What the advisory really gave us was a name and a clock. The name tells us which way the Pacific has tipped. The clock tells us roughly when to expect the effects to build and when they should fade. From here, the The sensible thing is to start at the beginning and work forward in order. So before we follow the numbers up through the spring and into this summer, it helps to be clear on what this pattern is in the first place and where it even got its name. El Niño is the warm side of a natural rhythm in the Pacific Ocean. Scientists call the full rhythm the El Niño Southern Oscillation, and they shorten that to a single word, ENSO, said like ENSO. The rhythm has 3 settings. There is the warm one, which is El Niño, there is the cool one, which is La Niña, and there is the in-between, called neutral, when the ocean sits near its average and neither side is in charge. The Pacific rocks back and forth between these settings, not on a fixed schedule but loosely, every 2 to 7 years. The thing that actually changes is the temperature of the ocean surface across a wide band near the equator, in the central and eastern Pacific. During El Niño, that surface runs warmer than normal. During La Niña, it runs cooler. The change can seem small in plain numbers, often just 1 to a few degrees. But the ocean there is enormous, and the air sits right on top of it. So a small steady change spread across that much water is enough to nudge the winds and the rainfall far beyond the tropics. The name itself comes from people who felt the warming long before anyone measured it. Fishermen along the coast of South America noticed that every so often the sea would turn unusually warm around the end of the year near Christmas. They called that warming El Niño, which is Spanish for the little boy, with the holiday in mind. For a long time, the warming was treated as a local quirk of the fishing season. It took until the middle of the 20th century for scientists to connect that coastal warmth to a far larger pattern stretching clear across the ocean, and to link it with shifts in the air pressure that a British scientist had charted decades earlier. That link is the heart of it. The ocean and the air are not 2 separate stories. They move together. When the water warms in the central and eastern Pacific, the air above it changes too, and that change in the air feeds back into the ocean. Once scientists saw that the sea and the sky were working as one system, the modern picture of El Niño fell into place, and the blended name, ENSO, came along to hold all of it. Here is a simple way to hold the whole seesaw in mind. Imagine a long bathtub of water laid out along the equator, with the warm end normally piled up in the west near Indonesia, and cooler water in the east near South America. The winds usually blow from east to west and help keep the warm water bunched in the west. During El Niño, those winds ease off or even turn around, and the warm water slides back toward the east. During La Niña, the winds blow harder than usual, and the warm water packs even more tightly to the west, leaving the eastern side cooler. That sloshing is the engine of the whole thing. Why should anyone outside the tropics care about a band of warm water near the equator? Because that water sets where the biggest thunderstorms of the tropics form, and those storms act like stones dropped in a pond. The waves they send through the atmosphere bend the high-altitude winds that steer weather across whole continents. So a warm Pacific does not stay in the Pacific. It reaches into the seasons of North America, South America, Africa, Asia, and beyond, mostly by shifting where the storms go and where the dry spells settle. One more point keeps the rest of this report honest. El Niño is a tilt, not a switch. It does not turn one kind of weather on and another off, it loads the dice. It makes some outcomes more likely in some places and less likely in others, while leaving plenty of room for any single season to surprise everyone. The strength of the event matters too. A stronger El Niño tends to tilt the odds harder, though even a strong one does not deliver the same effect everywhere. So that is the pattern that just switched on. The next question is why this arrival stands out at all. To see that, we have to look at the 2 years that came before it, and at how unusual it is for the Pacific to land back on the warm side now. To feel why this El Niño draws notice, it helps to remember what the Pacific had been doing right before it. For roughly the last 2 years, the warm side had been out of the picture. The ocean had spent that time on the cool side and then in the middle, not on the warm setting that just arrived. Run the clock back. The last strong burst of El Niño faded a couple of years ago, and the Pacific swung the other way into La Niña, the cool phase. That cool spell ran through much of last year and into the early part of this one. La Niña tends to cool the planet's average temperature a little while it lasts, like a hand easing off a dial. Then, as this year opened, the cool phase let go, and the ocean drifted back toward the middle. For a stretch of the spring, the Pacific sat in that neutral zone near its long-term average, leaning neither warm nor cool. That neutral stretch is the quiet part of the story. and it matters more than it sounds. When the Pacific sits in the middle, forecasters lose one of their best tools. The strong patterns, warm or cool, leave clear fingerprints that let them anticipate the coming seasons. Neutral leaves fewer. So in those months, the outlooks carried more shrug than usual, with rain, storms, and temperatures harder to call. The system was, in a sense, between chapters. What makes the new advisory stand out then is simply that the Pacific has picked a side again, and it picked the warm one. This is the first time in about 2 years that El Niño conditions have been in place. After a long cool spell and a quiet middle, the ocean has tipped back toward warmth, and it has done so with more vigour than many expected this early in the year. There is a useful contrast hiding in that swing. La Niña and El Niño are opposites in their machinery, and they tend to push the weather in opposite directions. The cool phase that just ended favoured one set of tendencies across the country and the tropics. The warm phase now beginning will favour close to the reverse in many places. So the country is not just getting a new pattern, it is getting a near flip from the one it had grown used to over the prior 2 years. A region that leaned dry under the cool phase may lean wet under the warm one, and the storm track that sat in one lane may shift to another. This back and forth is the normal life of the Pacific, not a malfunction. The ocean has rocked between these states for as long as we have records, on that loose 2 to 7 year beat. What is never fixed is the timing or the size of each swing. Some El Niños are weak and brief, some are strong and stubborn, some arrive late and fade fast. The pattern is reliable in its existence and unreliable in its details, which is exactly why each new event has to be measured fresh rather than assumed from the last. It also helps to set aside a common mix-up. People sometimes treat El Niño and La Niña as a kind of yearly weather, as if one is simply summer and the other winter. They are not. They are slower than the seasons and ride on top of them. A single El Niño can stretch across parts of 2 or 3 years, building, peaking and easing on its own schedule, while the ordinary seasons turn underneath it. The advisory that just went out is the opening of one such arc, not a forecast for a single month. So the gap of about 2 years is the first thing that makes this arrival worth a closer look. The Pacific has come off the cool side, passed through a quiet middle, and committed to warmth again. That alone would be a routine turn of the wheel. What lifts it past routine is how quickly the ocean has heated and how far the forecast says it may go. To see that, we have to go back to the first signs this warming gave, starting late last year, when the numbers first began to climb. The warming did not appear all at once in June. It built slowly, and the first signs showed up months earlier in the readings of ocean temperature that forecasters track week by week. Starting around the middle of December last year, the central and eastern Pacific began running a touch warmer than its average, and that warmth crept upward through the early part of this year. These readings come from a single, steady measurement. Scientists watch the surface temperature in a marked-off box of the tropical Pacific and compare it with the long-term normal for that spot and that time of year. The difference between the two is what they call the anomaly. A positive anomaly means warmer than normal. A negative one means cooler. Through the late winter and into spring, that number for the key region kept ticking up on the warm side, a sign the Pacific was leaning toward El Niño rather than away from it. The climb was real but modest at first. Across the late winter and early spring months, the warmth in that key box averaged only a small fraction of a degree above normal. The kind of gap that means little on a single day but adds up when it holds for weeks. By the time spring was well underway, the warm signal had grown clearer, and the running average had pushed higher. The ocean was not jumping, it was building, like a tide coming in rather than a wave breaking. Then came a wobble, and it is worth being honest about it because it shows how these forecasts actually behave. From late April into late May, the warming paused and even backed off a little. The positive anomalies, which had been climbing, dipped for a few weeks. To anyone watching closely, that pause raised a fair question. Was the warming stalling out before it ever reached El Niño? Could the Pacific slide back to neutral instead of committing to the warm side? That kind of stutter is common, and it is one reason forecasters do not call El Niño on the first warm reading. Short-term wobbles ride on top of the slower trend all the time. Winds shift for a week or two, and nudge the surface one way, then ease and let it drift back. A single dip does not settle anything. The honest move, and the one the agencies made, is to wait for the slower signal to reassert itself, Rather than to chase every jiggle in the line and reassert itself, it did. After that late spring pause, the warmth resumed its climb, and by the end of May, the running average in the key region had risen to roughly 1 degree above normal on the Celsius scale, which is a little under 2 degrees on the Fahrenheit scale that most Americans use day to day. That may still sound small. Spread across that much ocean and holding steady, it is not. It was enough to push the measurement firmly into warm territory and to set up the formal cool that came in June. This slow, uneven build carries a quiet lesson about how the Pacific works. The ocean is heavy and slow to change, far slower than the air. It does not flip overnight. It loads up over months, storing and releasing heat, and the surface readings we watch are the visible top of a much deeper change in the water below. By the spring, warm water had been gathering beneath the surface as well, ready to feed the warming we could see. That hidden reservoir is part of why forecasters grew confident the event would not only form but keep building. It also explains why the wobble did not derail anything. The deeper heat was still in place even when the surface paused. The pause was weather on top of a slower ocean trend, and the trend won out as the deeper warmth eventually surfaced and pushed the numbers higher. By June, the question was no longer whether El Niño would arrive, it was how strong it would get. So the line had been climbing for months, with one honest stumble along the way, and it had reached the doorstep of an official call. The next step is to look at that doorstep itself. What exact mark does the ocean have to cross, and for how long, before forecasters are willing to say the word? There is a specific bar the ocean has to clear before anyone declares El Niño, and it is lower than most people guess. The surface in that key stretch of the tropical Pacific has to run at least 0.5 degree Celsius above its long-term average. On the Fahrenheit scale, that is just under 1 degree. 0.5 degree may sound like almost nothing. The reason it counts is that it has to hold across that vast band of ocean, and it has to last. That last part is the real test. A single warm month does not earn the name. Forecasters want to see the warmth persist, or be clearly on track to persist, across a run of overlapping 3-month periods, roughly 5 of them in a row. They overlap these windows on purpose, sliding 3 months at a time so that one stray reading cannot tip the call by itself. Only when the warmth stretches across that run and looks set to continue do they treat the threshold as truly crossed. But the ocean number alone is not the whole gate. The agencies also insist on a matching change in the air above the water. The sea can warm for a short spell without the atmosphere joining in, and when that happens, the full El Niño pattern has not really locked in. So the forecasters look for the sky to respond as well, in ways we will get to shortly, before they are satisfied that both halves of the system have shifted. Ocean and air have to agree. This is why the June advisory was a careful, deliberate call rather than a quick reaction to a warm week. By the time it went out, the warmth had been building for months. The running average had cleared the 0.5 degree mark with room to spare, and the air above had begun to show the expected response. The forecasters were not predicting that El Niño might arrive. They were confirming that it had, with the slow signal holding and the models pointing the same way. It is worth pausing on how conservative this whole process is, because it shapes how much trust the announcement deserves. The agencies could call El Niño on the first warm reading and grab attention. They do not. They wait for the overlapping windows, for the matching shift in the air, and for the models to agree that the pattern should last. That patience costs them speed, but it buys reliability. When the advisory finally lands, it rests on a stack of evidence, not on a hunch. The cool side has its own mirror of this same rulebook, which helps show that the standard is even-handed. To declare La Niña, forecasters look for the same key region to run at least 0.5 degree below normal, again held across a run of overlapping 3-month windows, again with a matching response in the air. The bar is symmetric. Warm or cool, the ocean has to clear the same distance from normal and stay there, and the sky has to come along. There is no thumb on the scale toward calling one phase over the other. History shows why the wait pays off. There have been seasons when the Pacific warmed for a month or two, stirred talk of an oncoming El Niño, and then slid back to neutral before the threshold was ever truly met. Forecasters who had held their fire were spared a false alarm. The overlapping window rule exists precisely to filter out those near misses, so that the public hears the word only when the pattern has real staying power. That brings us back to this year. The warmth did wobble in late spring as we saw, but it recovered and then pushed well past the half-degree mark, and the air began to follow. The overlapping windows lined up. The models agreed the warmth should not only hold but grow. Every part of the checklist had been met, and so the call was made. Crossing the line is one thing. How far past the line the ocean has gone is another, and that is where this event starts to look less ordinary. By the middle of June, the readings were not sitting politely at the threshold, they had climbed well above it. So the natural next step is to look at exactly how warm the Pacific had become by then, and why those June numbers raised eyebrows. By the middle of June, the ocean was not hovering at the half-degree threshold it needed to clear. It had blown well past it. In the week centred on the 17th of June, the warmth in that key stretch of the tropical Pacific reached close to 1 7/10 of a degree above normal on the Celsius scale. That is more than 3 times the distance from normal that the formal call requires. To picture that, set it against the path the warming had taken. Through the early spring, the running average had been a small fraction of a degree above normal. By late May, it had climbed to about 1 degree above. By mid-June, a single week was reading near 1 7/10. The line was not just above the threshold, it was still rising, and rising fast for the time of year. What made forecasters take special notice was not only the size of the number but the calendar it landed on. Early summer is usually a sleepy time for this pattern. The ocean tends to be relatively calm then, with the bigger swings saved for later in the year. To see warmth this strong this early is unusual. In several of the monitoring areas, the surface was running at or near the warmest levels ever recorded for that point in the season. The Pacific was ahead of schedule. That phrase, warmest for the season, deserves a careful handle because it is easy to overread. It does not mean the ocean was hotter than it has ever been in absolute terms. It means that, compared with how warm that water usually is in June, this June was at or near the top of the record. The pattern was running early and strong, like a runner who is already well ahead at a point in the race where the field is normally still bunched together. This early strength is the main reason the June advisory carried more weight than a routine one. A borderline reading that just scrapes over the line in midsummer might fade by fall. A reading already running near record warmth in June, with deeper warm water still feeding up from below, is a different animal. It suggests an event with momentum, one more likely to grow than to fizzle. The numbers were not whispering, they were pointing clearly toward a strong winter ahead. It helps to remember where these readings even come from, because their reliability rests on the network behind them. The temperatures are not guessed. They are stitched together from satellites that scan the sea surface from orbit, from a line of buoys anchored across the tropical Pacific that measure the water directly, and from ships passing through. Those sources are blended into a single steady record that forecasters compare against decades of past readings. When that record shows near-record warmth, it is not one lucky sensor. It is many independent eyes agreeing. There is one more layer worth knowing about, and it sits beneath the surface entirely. Forecasters watch the heat stored in the upper ocean down a few hundred feet, not just the skin at the top. By this spring, a large pool of warm water had built up below the surface in the central and eastern Pacific. That hidden heat is fuel. As it rises and spreads, it keeps the surface warm and feeds the event forward. The presence of so much of it this year is a big part of why the models lean toward a strong peak rather than a quick fade. So the June numbers told a consistent story from top to bottom. The surface was running near record warmth for the season. The water below was loaded with extra heat. The trend was still climbing. None of that guaranteed a record event, but all of it tilted the odds toward a strong one. The ocean had not just crossed the line. It had cleared it with room to spare and kept going. Numbers in the water are only half of any El Niño though. For the pattern to truly take hold, the air above has to shift as well, and by June it was beginning to. So the next thing to understand is what happens in the sky over the Pacific, in a great loop of air that El Niño bends out of its normal shape. The ocean tells half the story, the air above it tells the other half, and the two have to move together for El Niño to be real. The piece of the sky that matters most here is a giant loop of air that runs along the equator across the Pacific. Scientists named it after the man who first charted the pressure shifts behind it, and they call it the Walker Circulation. You can think of it as a slow conveyor belt of air, thousands of miles long, that normally turns in one steady direction. In normal times, that belt runs because of a simple difference in temperature. The western Pacific near Indonesia sits over warm water. The eastern Pacific near South America sits over cooler water. Warm water heats the air above it, so the air rises in the west, drifts eastward high up, sinks over the cooler eastern ocean, and flows back westward along the surface as the trade winds. Air rises in the west, sinks in the east, and circles around. That loop is the everyday state of the tropical Pacific. El Niño throws a wrench into that loop. As the central and eastern ocean warms, the cool eastern end of the belt is no longer so cool. The temperature difference that drove the conveyor weakens. With less contrast to push them, the surface trade winds ease off, and sometimes they reverse, blowing from west to east instead of the other way. The rising branch of air, which normally sits in the west over Indonesia, slides eastward toward the warming water in the central Pacific. The whole loop sags and shifts. That shift shows up as a change in where the rain falls. Normally, the heavy tropical thunderstorms gather over the warm western Pacific, while the eastern side stays drier. During El Niño, the storms follow the warm water eastward. Rainfall drops over Indonesia and the nearby islands, and the surface pressure there rises, while the central and eastern Pacific sees more of the rising air and the storms. Forecasters watch exactly these signs. Less cloud and rain over Indonesia, higher pressure there, and weaker or reverse trade winds all tell them the atmosphere has joined the ocean. This is the matching response the agencies wait for before they declare El Niño. By June, those signs had begun to appear over the Pacific. The trade winds had slackened. The pattern of rising and sinking air had started to shift east. The pressure seesaw between the western and central Pacific had tilted in the El Niño direction. The sky was agreeing with the sea, and that agreement is what sealed the call. Why does a loop of air over the tropical Pacific matter to someone in Texas or California? Because when the rising branch of storms shifts east, it changes where the biggest tropical thunderstorms sit, and those storms send ripples through the high-altitude winds that steer weather far away. Move the storms, and you bend the steering currents downstream. That bending is how a change centered on the equator ends up nudging the winter storm track across North America. We will trace that chain in detail later. For now, the key point is that the Walker Loop is the bridge from the warm ocean to the wider world. It is also why a warm ocean alone is not enough. The agencies have learned, sometimes the hard way, that the sea can warm for a spell without the air loop responding. When that happens, the warmth stays bottled up in the tropics, and the broader effects never fully develop. The Walker shift is the difference between a warm patch of water and a true El Niño with reach. This year, the air responded, which is part of why forecasters expect real effects to follow in the cold months. There is one wrinkle in measuring all of this that has grown important in recent years, and it changes how we read the strength of the event. The plain ocean number, the one that crossed the half-degree line so easily, may be telling us a slightly inflated story compared with the older events we like to compare against. To understand why, and why forecasters now lean on a second, more careful yardstick, we have to look at the two different ways they measure how strong an El Niño really is. There is a quiet complication in measuring El Niño, and it has become important enough that forecasters now keep two yardsticks instead of one. The first is the old standby. It simply tracks the temperature in that key box of the tropical Pacific against its long-term average. That is the number that crossed the half-degree line and then climbed near 1 7/10 of a degree by mid-June. For decades, that single measure has been the main way to gauge an event. The trouble is that the whole ocean has been warming over the past few decades, not just the El Niño region. The tropics as a broad belt are running hotter than they used to. So when the key box reads, say, 1.5 degrees above its older average, part of that may simply reflect the general warming of all tropical water, not the El Niño pattern itself. The old yardstick can make a modern event look stronger than a like-for-like comparison with the past would suggest, because the baseline underneath it has crept upward. To handle that, forecasters built a second yardstick, a relative one. Its idea is simple, even if its name is not. You take the temperature in the El Niño box, then subtract the average warmth of the wider tropics around it. What is left is how much warmer the El Niño region is than the rest of the tropical ocean, rather than how much warmer it is than the past. By stripping out the broad background warming, this relative measure tries to isolate the El Niño signal alone, and to make today's events comparable with the strong ones of decades ago. The agencies have been watching both numbers side by side for several years now. After comparing them against how the atmosphere actually responded, they concluded that the relative measure tracks the real-world effects more closely. It lines up better with the shifts in that great loop of air over the Pacific, and so it gives planners a more honest read on how much punch an event will carry. For that reason, the relative yardstick has become the agency's preferred guide to strength, even as the older number stays in view. Here is where this year gets genuinely interesting, and a little two-sided. By the old yardstick, the ocean signal this spring looked very strong, even potentially record-breaking, because so much heat had piled into the upper Pacific. Some forecasts using that measure raised the possibility of an oceanic event rivaling the Great El Niño of the late 1990s, one of the most intense ever recorded. The raw ocean heat really is that large. By the relative yardstick, though, the picture is more moderate. Once you subtract the broad warming of the surrounding tropics, this event looks strong but less extreme, closer to a solid, moderate to strong event than a record smasher. And the atmosphere, the part that actually drives the weather we feel, may follow that calmer reading more than the dramatic one. In plain terms, the ocean may set records in raw heat, while the El Niño that reaches our skies behaves more like a strong but ordinary one. That gap between the two measures is not a contradiction. It is the honest state of the science right now. It tells us to hold two ideas at once. The Pacific is carrying a remarkable amount of heat, which is real and worth respecting, and the felt strength of this El Niño, the part that bends the winter storm track and tilts the odds for rain and drought, may land a notch below what the raw ocean number alone would suggest. The truth sits between the two, and forecasters say so plainly, rather than picking the scarier headline. Keeping both yardsticks in mind guards us against two mistakes. It stops us from shrugging off a genuinely large pool of ocean heat, and it stops us from promising a record-breaking winter that the atmosphere may not deliver. With that balance in place, we can look squarely at the question the title raises. In what specific, measurable way is this El Niño not normal, and how confident are the forecasters in that strength? So what exactly makes this event stand out, in plain numbers rather than impressions? The clearest sign sits in the forecast for how strong it may become. At the time of the June advisory, the agencies put the chance of this El Niño reaching the very strong level at 63% for the heart of the winter, the stretch from November into January. Very strong is the highest category they use. Crossing into it means the ocean in that key region would run 2 full degrees Celsius, or more above normal, a high bar that only a handful of past events have cleared. The number itself is striking, but the jump behind it is what really caught attention. Just 1 month earlier, in the May outlook, that same chance of a very strong event had stood at only 37%. In the space of a single update, the odds nearly doubled. That kind of leap does not happen often. It reflects how quickly and how strongly the ocean heated through late spring and into June, far faster than the May forecast had assumed. The Pacific outran its own forecast and the odds had to catch up. This is the heart of the title's claim, and it is fair to state it plainly. An El Niño that has a better than even chance of reaching the top category is not an ordinary event. Most El Niños are weak or moderate. They come and go without ever threatening the very strong mark. To have the odds tilt past 50-50 toward that highest level, this early in the year, is the part that earns the word unusual. The forecasters are not saying it will certainly be a giant. They are saying the most likely path now runs toward the strong end of the scale. The informal name for an event at that level has already started circulating. People in the media often call a very strong El Niño a super El Niño. It is a loose, unofficial term, not something the agencies use in their technical language, but it captures the public sense that this one is big. When you hear Super El Niño this year, it points to that very strong category, the same one with the 63% odds attached. It is worth being careful about what those odds do and do not promise. 63% is a strong lean, not a certainty. It leaves a real chance, better than 1 in 3, that the event peaks a notch lower, as merely strong rather than very strong. Forecasters are upfront about that spread. They give a probability rather than a flat prediction precisely because the ocean still has months to run and could land anywhere across a range. The honest takeaway is a tilt toward the high end, with room for something less. The agencies add one more caution that is easy to skip past but matters a great deal. Even a very strong El Niño does not force its expected effects everywhere. A bigger event tilts the odds harder toward the typical outcomes, but it does not guarantee them in any one place. Past giants have left some regions behaving exactly as the textbook said, and others stubbornly doing their own thing. Strength raises the chances, does not hand out promises. That line will be worth remembering when we get to the specific forecasts for different parts of the country. There is also a timing point folded into these odds. The peak is expected in the cold months, roughly from late fall through midwinter, not now. The 63% figure is pinned to that window for a reason. El Niño builds toward winter and tends to reach its greatest strength then. So the unusual part of this event is partly a forecast about a season still ahead, not a description of how things feel today. The strength is coming, the models say, more than it has already arrived. Put it together, and the picture is clear without being alarmist. This El Niño has crossed the threshold early, warmed faster than expected, and now carries better than even odds of reaching the top tier by winter. That is what lifts it out of the ordinary. To judge what a top-tier event can actually do, the natural move is to look back at the few past El Niños that reached this level, and at what they brought when they did. To judge what a very strong El Niño can do, it helps to look at the small club of past events that reach that level, because only a few ever have. When forecasters talk about the giants, 3 winters come up again and again. There was the strong El Niño of the early 1980s, the one in the late 1990s, and the one in the middle of the last decade, around 2015 into 2016. Those 3 are the modern benchmarks for what a top-tier event looks like. Each of those winters left a deep mark, and together they sketch the range of what a strong El Niño can bring. They reshaped storm tracks, swung regions from drought to flood and back, and pushed global temperatures upward in their wake. They are the cases scientists reach for when they want to picture a strong year, not because this year will copy any one of them, but because they show the scale of what is possible when the Pacific runs this hot. The late 1990s event is the one this year gets compared with most often, and for a specific reason. In raw ocean heat, that earlier event stands as one of the most intense ever measured. The forecast this spring, using the older yardstick we discussed, raised the possibility that this year's ocean could rival it in sheer warmth. That is a high bar. It is part of why some early coverage reached for dramatic language. The pool of heat in the Pacific really is, by that measure, in the company of a historic event. Here is where the 2 yardsticks from earlier earn their keep. The raw ocean heat may rival that late 90s giant. The relative measure, the one that strips out the broad warming of the tropics, paints something more moderate, and the atmosphere may follow that calmer reading. So the honest comparison is split. In ocean temperature, this year reaches toward the historic high end. In the felt weather-driving strength, it may land a step below those benchmark winters. Both things can be true at once, and saying so keeps the comparison fair rather than breathless. It is worth holding on to why these past events differed from one another, because it warns against assuming this one will behave like any of them. Each of those 3 strong winters carried its own imprint. They did not deliver the same weather to the same places. One brought punishing storms to parts of the country that another left relatively calm. The timing of their peaks varied. Their effects on drought and flood landed in different spots. That variety is the rule, not the exception, even among events of similar size. The director of the Weather Service made exactly this point when the advisory went out, and it bears repeating here. Every El Niño, he said, is unique, with its own imprint on the weather. The historical giants are a guide to scale, not a script for this season. They tell us roughly how big the effects can grow. They do not tell us which neighbourhoods will flood or which reservoirs will fill. This year will write its own version. There is also a sobering thread that runs through the strong years, tied to global temperature. The biggest El Niños tend to nudge the whole planet's average temperature upward, often most strongly in the months after they peak. The strong event of the late 1990s helped make its year one of the warmest of its time. The one in the middle of the last decade did the same. We will return to that global push later, because this year's event lands on top of an already warm world, and that combination is part of what scientists are watching. So the company this event keeps is impressive but mixed. In raw ocean heat, it reaches toward the historic high end. In felt strength, it may land a notch below the giants, and whatever its size, it will carry its own imprint rather than repeat an old one. That raises a fair question for anyone feeling ordinary summer weather right now. If this event is so notable, why does the season outside feel so unremarkable? The answer lies in El Niño's timing and in why summer is the quiet part of its life. If this El Niño is so notable, why does the weather outside feel so ordinary right now? The answer is timing. El Niño is a winter creature, and summer is the quiet stretch of its life. The pattern is present and building, but its grip on day-to-day weather stays loose through the warm months and tightens only as the year turns cold. The reason traces back to that great loop of air over the Pacific. In summer, the contrast between the equator and the higher latitudes is gentler, and the high-altitude steering winds sit farther north and run weaker. El Niño's nudge to those winds has less to push against. The warm ocean is sending its signal, but the atmosphere over North America is in a relaxed summer posture, less able to carry that signal into sharp, organised weather. The lever is there, the arm pulling it is slack. Come winter, the setup changes. The temperature contrast between the tropics and the poles sharpens. The steering winds strengthen and shift, and they become far more sensitive to the shove El Niño gives them. The same warm Pacific that barely moved the summer weather can now bend the winter storm track in a clear and lasting way. That is why forecasters pin the strong effects and the strong odds to the cold months rather than to now. El Niño does its loudest work when winter is already primed to listen. This explains the strange gap many people feel between the headlines and their own backyard. The announcement said a possibly historic event has arrived. The afternoon outside looks like any other early summer. Both are true. The ocean has tipped, the forecast leans strong, and yet the felt weather waits. There is a built-in delay between the pattern locking in and the pattern being felt, and that delay runs from summer toward winter. Nothing is wrong with the forecast. The clock is simply slow on purpose. It is a little like a long fuse. The match was struck in June, when the advisory went out and the ocean crossed the line. The effects burn down the fuse through the summer and into the fall. The flare comes in winter, when the steering winds are strong enough to translate the warm ocean into shifted storm tracks, wetter souths, drier norths, and milder cold seasons across parts of the country. By the time most Americans feel this El Niño in their own weather, the calendar will likely read late fall or winter. That timing also shapes how forecasters talk about the event through the summer. Their monthly updates in these warm months are mostly about the ocean and the odds, not about felt impacts, because there are few felt impacts yet to report. They are tracking how hot the Pacific runs, how the air loop responds, and how the winter outlook firms up. The real test of the forecast, the part the public will judge, comes later, when winter weather either matches the tilted odds or surprises everyone. There are a few summer effects worth a brief, honest mention, so the quiet does not seem total. El Niño tends to suppress hurricane activity in the Atlantic, and that influence runs through the summer and fall season, which we will cover on its own. It also warms the ocean surface in ways that can stir marine life and heat along certain coasts. So summer is not entirely silent. But for most people on land, the headline effects on rain, snow and winter temperature are still over the horizon. Holding this timing in mind guards against two opposite errors. It stops anyone from deciding the forecast failed just because June felt normal, and it stops anyone from bracing for dramatic weather that is not due yet. The sensible posture for the summer is patient attention. Watch the ocean readings and the monthly updates, and save the real weather watching for fall and winter when the grip tightens. So the calm outside is not a sign the event is weak. It is a sign the event is early. The machinery is in place and loading. When winter arrives, the first and clearest way it will show itself is in the path the storms take across the country. That path is steered by a fast river of air high overhead, and El Niño is about to nudge it south. The clearest way a winter El Niño announces itself over the United States is by moving a river of air that most people never see. High above the ground, near the altitude where jets fly, fast ribbons of wind circle the planet. Forecasters call them jet streams, and they act like rails that storms ride along. Where the jet goes, the storms tend to follow. El Niño's main trick over North America is to shift one of those rails. In a typical winter, the jet stream coming in off the North Pacific aims toward the Pacific Northwest and the northern states, carrying its parade of storms across the upper part of the country. That is the usual lane. El Niño nudges it out of that lane. By warming the central and eastern tropical Pacific, the pattern feeds extra energy into the subtropical branch of the jet, the more southern ribbon, and pulls the active storm track southward with it. The mechanism, in plain terms, runs like this. the warm ocean near the equator fires up more thunderstorms in the central Pacific. Those storms pump heat and air upward, and that rising air has to come down somewhere, strengthening and shifting the high-altitude winds downstream. The net effect over North America is to energize the southern branch of the jet and steer it across the southern tier of the country. The storms that ride it get aimed at the south rather than the north. That single shift drives most of the winter weather people associate with El Niño, and it is worth seeing how one change fans out. When the storm track slides south, the southern states, from California across Texas to the southeast, sit more often in the path of incoming storms. They tend to turn wetter and stormier than usual. Meanwhile, the northern interior, now bypassed by much of the storm parade, tends to turn drier. One move of the rail, and the map of wet and dry redraws itself. The same shift carries a temperature signal through a slightly different door. With the storm track and its clouds and rain favouring the south, that southern tier often runs near normal or a touch cooler than usual through winter. The north, meanwhile, frequently runs milder, partly because the coldest outbreaks of Arctic air get nudged aside less often, and the pattern leans warmer up there. So the country tends to split, with a cooler, wetter south and a milder, sometimes drier north. We will walk each of those pieces in turn. It helps to keep the limits of this in view, the same caution as before. The jet stream shift is a tendency, not a wall. The rail moves south on average, across the whole winter, but individual storms still wander and cold snaps still break through. A southward shifted jet makes certain weather more likely week to week, not guaranteed on any given day. The strength of this El Niño raises the odds that the shift will be clear and lasting, but it does not lock any single forecast in place. This southward shift is also why El Niño winters often end the same season's drought worries in the south, while raising flood worries instead. A region that spent a dry stretch under the cool phase can find itself in the bullseye of repeated storms once the rail drops south. That swing from too little water to too much is one of the signature stories of a strong El Niño, and parts of the southern United States have lived it before, sometimes to dramatic effect. So the jet stream is the hinge. It connects the warm tropical ocean to the weather on American ground, and it does most of its work by sliding south for the winter. Everything that follows in this report, the wet south, the dry interior, the mild north, the flooding risk along the coast, flows from that one shift. The sensible place to start unpacking it is where the storms are most likely to gather. So we turn next to the southern tier and to the wetter, stormier winter that the forecast favours there. The southern tier of the country is where the storms are most likely to gather this winter, and that is the first felt effect to expect. When the jet stream drops south, the band of states running from California across Texas and the Gulf and up into the southeast moves into the favoured path. The forecast leans toward a wetter than average winter there, with more rain along the warmer stretches and more chances for snow and ice in the colder ones. What does wetter actually mean for daily life? It means more storm systems passing through, spaced closer together, with rain that adds up over the season rather than arriving in one burst. For a region that often runs dry in winter, that can be welcome at first. Reservoirs that sat low can refill. Soil that cracked in drought can soften. The early part of a wet El Niño winter often reads as relief, especially across the southwest and parts of Texas that have known hard dry spells. The relief has an edge to it though, and honesty means naming it. The same parade of storms that fills reservoirs can, if it keeps coming, push rivers high and saturate the ground past what it can hold. Wet soil sheds the next storm's rain straight into streams instead of soaking it up, so a winter that starts as drought relief can tip, storm by storm, toward flood risk in low-lying areas and along swollen rivers. That swing from too little water to too much is a classic arc of a strong El Niño across the south. The temperature side shapes what falls from those storms. Across the southern tier, El Niño winters often run near normal or a little cooler than usual, most clearly from Texas eastward to the southeast. That cooler lean, paired with the extra moisture, raises the odds of wintry weather in places that do not see it often. A storm that would have brought plain rain in a mild year can bring ice or snow when the air runs a few degrees colder. The deep south and the southern plains sometimes get their rare winter storms in exactly these patterns. History gives the south good reason to take a strong El Niño winter seriously. In past strong events, parts of the Gulf Coast and the southeast saw repeated heavy rain, swollen rivers, and stretches of flooding. California, on the western end of this same southern band, has its own dramatic history with these winters, which we will come to shortly because the water story there is large enough to stand on its own. The pattern's fingerprint on the south is one of the more reliable ones, though even here it tilts the odds rather than settling them. For people living across this band, the calm and standard advice is the kind worth following any wet winter. Keep an eye on local forecasts as storms line up, especially when several are due in a row. Know whether your home sits near a floodplain or a low spot that gathers water. Clear gutters and drains before the season so water has somewhere to go. None of this is cause for worry today. It is the ordinary readiness that turns a stormy winter from a hazard into an inconvenience. It also helps to set expectations about pace. A wetter winter does not mean constant rain. It means more systems over the course of the season, with dry breaks in between. The risk builds across weeks, as the ground stays damp and each new storm has less room to absorb. The dangerous moments tend to come late in a wet stretch, when soils are already full, rather than at the first storm. Watching how the season accumulates matters more than reacting to any single day. One more point keeps this fair. The wet lean is a favoured tendency, not a promise of a soaking everywhere in the south. Some corners of the region may see a near-normal winter even in a strong event, and the heaviest rain may concentrate in spots no one can pin down months ahead. The forecast tilts the odds toward wet across the band as a whole. It cannot tell any one town exactly how much it will get. The strength of this event raises the confidence, without erasing the spread. So the south sits in the wettest, stormiest part of the El Niño map, with relief and risk riding in on the same storms. If the southern tier is where the water gathers, there is a mirror image to the north of it, where the same jet stream shift tends to leave the land drier. That dry side is the next piece of the pattern to understand. For every region that turns wetter under El Niño, another tends to turn drier, and the same southward shift of the jet stream draws that line. When the storm track slides toward the southern tier, the lands it used to cross get bypassed. Two areas stand out in the forecast for a drier than average winter. One is the northern Rockies and the northern interior. The other is the band through the Ohio Valley and the Tennessee Valley in the country's middle. The reason is the flip side of the wet south. Storms ride the jet, and when the jet drops south, the northern and central interior lose their share of the parade. Fewer systems track across the northern Rockies and the upper interior. Fewer organized storms sweep through the Ohio and Tennessee valleys. With less moisture arriving, those regions lean drier through the cold months, sometimes noticeably so in a strong event. The water that the south gains, in a loose sense, the northern interior goes without. In the northern Rockies, a dry winter carries a particular weight because of snow. The mountain snowpack that builds up through winter is a savings account for water. It melts through spring and feeds the rivers and reservoirs that farms and cities lean on all summer. A dry El Niño winter can leave that snowpack thinner than usual. The shortfall may not be felt in January. It shows up later in a leaner spring melt and tighter water supplies through the following summer. The drought lean up north can outlast the season that caused it. The Ohio and Tennessee valleys feel a dry winter differently, more in the ground and the rivers than in mountain snow. A drier than average winter there can lower river levels and leave soils short of the moisture heading into spring planting. It is usually a gentler story than the flood risk down south, but it has its own costs for farms, for river traffic, and for the water that communities draw on. A quiet, dry winter is less dramatic than a stormy one, which is part of why it gets less attention, even as it shapes the year ahead. It is worth holding the same honesty here that applied to the wet south. The dry lean is a tendency, not a sentence. A drier favoured winter still has storms in it. Cold fronts still pass. Snow still falls in the mountains, just less of it on average across the season. The forecast tilts the odds toward dry in these regions. It does not promise a winter without weather. Any single storm can buck the trend, and a strong event tilts the odds harder without removing the spread. There is also a temperature thread that often runs alongside the dry one up north, and it tends to soften the picture. The northern interior frequently leans milder under El Niño, which we will take up on its own next. A milder, drier winter is, in some ways, an easier one to live through day to day, with fewer brutal cold snaps and fewer big snowstorms to dig out from. The cost is not in the daily discomfort. It is in the water that does not arrive, and that cost is paid later. For people in these drier favoured regions, the calm guidance is mostly about the long view rather than any single storm. Where water is tight, a dry winter is a reason for water managers to plan carefully and for communities to mind their supplies heading into spring and summer. For most households, a drier winter asks little in the moment. The watching that matters is seasonal, tracking how the snowpack and the soil moisture build, or fail to, across the whole cold stretch. So the dry side of El Niño is the quieter half of the same coin as the wet south. One jet stream shift fills the southern reservoirs and empties the northern snowpack in a rough trade across the map. The dry lean up north often pairs with a milder one, and that mildness is itself a clear and widely felt part of an El Niño winter. So the next piece to look at is the warmth that tends to settle over the northern half of the country when this pattern takes hold. The most widely felt comfort of an El Niño winter for the northern half of the country is warmth. Across the northern tier of the United States and up into much of Alaska, the pattern tends to favour a milder winter than usual. It is one of the more dependable signals El Niño carries, and for many people it lands as a gentler season rather than a harsher one. The warmth comes through the same machinery that steers the storms. With the jet stream and the active storm track shifted south, the northern states spend less time under the path of deep cold outbreaks. The bitter Arctic air that plunges south in some winters gets nudged aside more often, kept bottled up to the north rather than spilling down across the upper Midwest and the northern plains. Fewer deep cold spells spread across the season add up to a winter that averages milder than normal. The north stays warmer partly because the worst cold simply visits less often. For daily life, a milder northern winter reads as relief in plain ways. Heating bills can run a little lighter. Roads stay clear more of the time. The grind of deep cold and heavy snow eases. In the northern states that know hard winters well, an El Niño year often feels like a break, a season where the coldest stretches are shorter and the thaws more frequent. There is real benefit in that, and it is honest to name the upside as clearly as any risk. Alaska tends to share in this warmth, and the effect there can be pronounced. Much of the state leans warmer than average during El Niño winters, which touches everything from daily comfort to the timing of snow and ice. In a place where winter shapes so much of life, even a modest warm lean is felt. As always, it is a tendency across the season, not a guarantee for any week, but the lean toward mild is part of the standard El Niño picture for the far north. The milder lean does carry quieter costs, and fairness means noting them beside the comfort. Warmer winters can shorten the season for snow that some economies depend on, from winter recreation to the snowpack that feeds spring water. A warm spell can melt snow early or fall as rain instead, which ties back to the water worries of the drier northern interior we just discussed. Mildness that feels pleasant in town can mean a thinner mountain snowpack and a leaner water year to come. The benefit in the moment and the cost down the line sit side by side. It is important to keep this warm lean in proportion because it is easy to overstate. A milder winter does not mean a winter without cold. Arctic outbreaks still happen in El Niño years. Snow still falls, sometimes heavily, when a storm and a cold snap line up. The pattern shifts the averages, trimming the frequency and depth of the cold without abolishing winter. People in the north should expect a season that leans gentle on the whole, not one stripped of its hard days. Any single cold snap can still bite. There is also a north-south contrast worth holding in one frame, because together the pieces describe the whole country's winter. The southern tier leans cooler and wetter. The northern tier leans milder, and across its interior drier. The storm track that brings the south its rain is the same one whose absence leaves the north both warmer and drier. One shift in the high-altitude winds writes both halves of the story at once, a cooler, stormier south and a milder north. Seeing them together makes the pattern coherent rather than a list of scattered effects. So the north can reasonably expect a gentler winter, with the cold visiting less often and the snow piling up less deep, while keeping in mind the water cost that mildness can carry into the following year. That covers the broad north-south split across the country's interior. There is one part of the map, though, where El Niño's water story grows large enough to stand on its own. The west coast, and California in particular has a long and dramatic history with these winters, and that coastal water story is the next piece to take up. The West Coast deserves its own chapter, because El Niño's water story there can grow larger than anywhere else in the country. California sits at the western end of that wet southern band, and in strong events it has seen some of the most dramatic winters on record. When the storm track drops south and aims at the state, the rain and mountain snow can arrive in volumes that reshape a whole year, for better and for worse. Part of that story comes through long, narrow plumes of moisture that stream in off the Pacific. Forecasters call them atmospheric rivers, and the name fits. Each one is a ribbon of very moist air, sometimes carrying as much water as a great river, aimed at the coast. When a strong El Niño helps steer a string of these at California, they can drop enormous amounts of rain on the lowlands and deep snow on the mountains in a matter of days. A few well-aimed plumes can swing the state from drought to flood in a single stormy stretch. That swing is the heart of California's complicated relationship with these winters. The state needs the water. Its reservoirs and its mountain snowpack carry it through long, dry summers, and a wet El Niño winter can refill both, easing drought that may have gripped the land for years. The same storms that bring that relief, though, can overwhelm rivers, saturate hillsides, and set off flooding and mudslides, especially on slopes left bare by past wildfire. The gift and the hazard ride in on the same clouds. There is a second, quieter water risk along the coast that strong El Niños raise, and it is worth naming plainly. During these events, sea levels along parts of the west coast tend to run a little higher than usual, as warm water expands and shifting winds pile water against the shore. That extra height makes high tide flooding more likely. On certain days, when a high tide lines up with a storm, water can push into low coastal streets and neighbourhoods that normally stay dry. It is usually a nuisance rather than a disaster, but it is a real and recurring feature of El Niño along the coast. California's history with strong events gives all of this weight. In past top-tier El Niño winters, the state has seen storms that filled reservoirs and snowpack to overflowing, alongside flooding, slides, and coastal damage that took a real toll. Those winters are remembered both as drought breakers and as hard seasons. They are the reason water managers and emergency planners in the state watch an El Niño advisory closely, and why a strong forecast prompts careful preparation rather than simple relief. The honest caveat applies on the coast as firmly as anywhere. A strong El Niño tilts the odds toward a wet California winter, but it does not guarantee one. The state has lived through strong events that delivered less rain than expected, where the storm track wandered, or the biggest plumes aimed elsewhere. The atmospheric rivers that do the heavy lifting are hard to forecast far ahead, and a season's outcome can hinge on just a few of them. So the lean is toward wet, with real uncertainty in how much and where. For people along the west coast, the standard, calm preparation is the sensible response to that uncertainty. Where homes sit below hillsides, especially slopes burned in recent fires, it is worth knowing the local warnings and the routes out. Where streets flood at high tide, it helps to track the days when storms and tides line up. Clearing drains, knowing the floodplain, and heeding official guidance during big storms turn a dramatic winter into a manageable one. None of it is cause for alarm now, in the quiet of summer. It is groundwork for a season still months away. So the West Coast carries the heaviest version of El Niño's water story, with relief and risk braided tightly together, and a coast that runs a little higher than usual besides. That covers the pattern's reach across American land, from the wet south to the dry interior, the mild north, and the storm-prone west. El Niño's influence does not stop at the coastline, though. It reaches out over the ocean too, and one of its largest effects there is on the hurricanes of the Atlantic. That connection is the next thread to follow. El Niño's reach extends well past the land, and one of its largest effects over the ocean works in a direction many people find surprising. A strong El Niño tends to quiet the Atlantic hurricane season. The same pattern that can stir up a stormy winter on land often calms the tropical Atlantic through the summer and fall, tilting that basin toward fewer and weaker storms. The tool it uses is something forecasters call wind shear. Shear is simply a change in the wind with height, when the wind blows one way near the surface and a different way, or much faster, higher up. Hurricanes are tall, stacked engines of rising air, and they need a fairly calm column to grow, Strong shear tears at that column. It tilts and shreds a developing storm before it can organise, or stops it from forming at all. Where shear is high, hurricanes struggle. El Niño raises that shear across the tropical Atlantic, and the chain runs back to the warm Pacific. The warm equatorial Pacific fires up extra thunderstorms there, and the air rising over those storms spreads out high in the atmosphere and sinks and shifts the winds far downstream, including over the Atlantic. The result is stronger high-altitude winds over the very waters where Atlantic hurricanes are born. That added shear acts like a brake on the season, holding storm development down. This year's forecasts reflect exactly that brake. With El Niño developing, the outlook for the 2026 Atlantic hurricane season leans below normal. The official seasonal outlook, issued in late spring, called for below-average tropical activity in the Atlantic. A respected university team that has forecast these seasons for decades trimmed its numbers further as El Niño firmed up, calling for a notably quiet season, with the count of named storms, hurricanes and major hurricanes all running below the long-term average. El Niño was named as the main reason. To put rough shape on it, that university forecast pointed toward only a handful of named storms for the whole season, of which a few might reach hurricane strength, and perhaps 2 could grow into major hurricanes. If that holds, it would land well below the long-run average by something like 40%. The team also lowered the odds of a major hurricane striking the United States coast, compared with a typical year. The whole basin, in other words, is forecast to run quieter than usual, and El Niño is the chief reason why. Here is the caution that has to ride alongside that good news, and the experts state it firmly every year. A quiet season is not a safe season. It takes only one storm reaching the coast to make a bad year for the people in its path. Below-average seasons have produced damaging, deadly landfalls before. The forecast lowers the odds of a busy basin. It does not lower the importance of being ready along the coast. Anyone in a hurricane-prone area should prepare for this season exactly as they would for any other, regardless of the seasonal outlook. It is also worth being clear about what the forecast can and cannot say. A seasonal outlook speaks to the basin as a whole, the rough number and strength of storms expected over months. It cannot say whether a particular coast will be hit, or when. Those are questions only the short-range forecast can answer, in the days before any individual storm. So the El Niño signal is best read as a tilt in the background odds, useful for planning and insurance and resource decisions, not as a promise about any one stretch of shoreline. So El Niño tends to press down on the Atlantic, and this year's quiet forecast carries its fingerprint, with the standing reminder that one storm is enough to matter. That is the calming side of its ocean reach. There is a flip side, though, on the other side of the continent. The same pattern that shears the Atlantic tends to do the opposite over the eastern and central Pacific, where it can stir storms up rather than down. That mirror image effect is the next piece to take in. The break El Niño puts on the Atlantic comes with a mirror image on the other side of the continent. The same pattern that shears Atlantic storms apart tends to do the opposite over the eastern and central Pacific. There, El Niño often eases the conditions that hold hurricanes back, and the basin can turn more active than usual. What calms one ocean stirs the other. The reason is the flip side of the shear story. Over the Atlantic, El Niño piles up the high-altitude winds that tear storms apart. Over the eastern and central Pacific, closer to the warm water driving the whole pattern, those upper winds tend to relax instead, and the ocean surface runs warmer. Warmer water is fuel for hurricanes, and lighter shear lets them stand up and grow. So the very same El Niño that suppresses the Atlantic can give the Pacific basins a push, raising the odds of more storms and stronger ones there. This year's outlooks carry that signal too. Alongside the call for a below-normal Atlantic season, forecasters lean toward above-average tropical activity in the eastern Pacific, the stretch of ocean off the western coast of Mexico and out toward Hawaii. It is the natural counterpart to the quiet Atlantic. The storm energy does not vanish under El Niño. It largely shifts basins, moving toward the Pacific side where the pattern's influence turns favourable for development. For most people in the mainland United States, an active eastern Pacific season feels distant, and often it is. Many of those storms spin out over open water and weaken before reaching land, or curve away from populated coasts, but not always. The remnants of eastern Pacific storms can sweep moisture into the southwestern United States, feeding heavy rain and flash flooding across the desert southwest in late summer and fall, and the central Pacific basin includes Hawaii, where a more active season raises the odds that a storm passes near or strikes the islands. The Pacific side is not as remote from American interests as it first appears. This basin-to-basin trade is one of the clearest demonstrations of how El Niño works as a single connected system, rather than a bundle of separate effects. The warm water near the equator is the engine. Its influence radiates outward through those high-altitude winds, pressing down on storm formation in one ocean while lifting it in another. The Atlantic and the Eastern Pacific sit on opposite ends of that seesaw. Reading them together, rather than one at a time, shows the pattern's logic at work. The same honest caveats carry over here as well. An above-average Eastern Pacific season is a tilt in the odds, not a guarantee, and it speaks to the basin as a whole, rather than to any single coast or island. Whether a particular storm threatens land, and when, is a question for the short-range forecasts in the days before it arrives, not for the seasonal outlook months ahead. The El Niño signal sets the background. The day-to-day forecasts fill in the rest. For people in the regions that the Eastern and Central Pacific can touch, the calm guidance mirrors what holds for any storm-prone coast. In Hawaii, an active season is a reason to keep the usual preparations in mind through the summer and fall, knowing the odds of a near pass run a little higher than normal. In the desert southwest, it is worth being alert to flash flooding when tropical moisture surges north, since dry ground sheds heavy rain fast and washes can fill in minutes. As always, these are ordinary readiness steps, not cause for worry today. So the Pacific side of El Niño runs opposite to the Atlantic, trading a quieter eastern ocean for a busier one, and reminding us that the pattern moves storm energy around rather than erasing it. The ocean effects of El Niño are not only about storms though. The warm water itself reaches down into the sea's living systems, changing where creatures go and what coastal communities pull from the water. That living side of the story is the next thread to follow. The warm water that drives all of this does more than steer storms. It reaches down into the living ocean, changing where creatures go and what coastal communities can pull from the sea. El Niño's effects on marine life are among its most direct, because the heat is not a distant signal there. It is the water the animals live in. The core change is in the food at the base of the ocean. Along parts of the Eastern Pacific, cool, nutrient-rich water normally wells up from below and feeds a bloom of tiny plants and animals that everything else eats. El Niño warms the surface and weakens that upwelling. With less of the cool, nutrient-laden water rising, the base of the food web thins. The tiny life that feeds the fish, which feed the bigger fish, and the birds and the mammals grows scarcer in places. The whole chain feels it from the bottom up. When the food shifts, the animals follow, and that reshuffles the map of where sea life can be found. Warm water species move into areas that were once too cool for them, while cold water species retreat, heading farther north or sinking into deeper, cooler water to find the conditions they need. Forecasters and fishery scientists watch these movements closely. One example noted this year is the market squid, a staple of California waters, which tends to move toward cooler seas to the north during El Niño, drifting away from the fishing grounds that usually depend on it. That kind of movement lands hard on fisheries and the people who run them. A fishing community built around a species that suddenly shifts north, or thins out, can face a lean season through no fault of its own. The fish are not gone from the world. They have moved to follow the conditions they need. But for boats tied to particular grounds and particular catches, a strong El Niño can mean travelling farther, catching less, or switching targets. The disruption ripples from the water into harbours, markets, and livelihoods along the coast. There is another marine effect that touches people more directly, and it is worth naming with care. Past strong El Niños have, at times, encouraged blooms of certain harmful algae along the west coast. These are surges of tiny organisms that can release toxins into the water. When shellfish feed on them, the toxins can build up in the shellfish, which is why health officials sometimes close shellfish harvesting during these events. It is a real public health link, and the standard calm response is simply to heed local advisories about which seafood is safe to gather and eat. Following those notices is the whole of what most people need to do. The warmth itself can stress ocean life directly, beyond shifting the food supply. Stretches of unusually hot ocean water can harm sensitive systems like kelp forests and the creatures that shelter in them, and they can strain fish already living near the warm edge of their range. The living ocean is tuned to a range of temperatures, and a strong, prolonged warm spell pushes parts of it past comfortable limits. These effects vary from place to place and from event to event, which fits the larger truth that every El Niño leaves its own particular mark. It is fair to keep these marine effects in proportion. They are real and locally important, especially for fishing communities and coastal health, but they unfold gradually and unevenly, and they ease as the event fades and the ocean cools back toward normal. The sea life that moves tends to move back. The blooms subside, the upwelling returns. El Niño rearranges the living ocean for a season or two rather than remaking it. The disruption is genuine and temporary at once. So the warm Pacific writes a living chapter as well as a weather one, thinning the food web in places, sending creatures searching for cooler water, and raising a few coastal cautions that local notices handle well. To this point, the story has stayed mostly within the Pacific and North America, but a strong El Niño does not respect those bounds. It nudges the temperature of the whole planet, and that wider global push is the next piece to take up. A strong El Niño does not stay regional. It nudges the temperature of the whole planet upward, and that global push is one of its most far-reaching effects. The warm Pacific releases a great deal of heat into the atmosphere, and spread across the globe, that release tends to lift the average temperature of the entire Earth for a year or more. El Niño years often rank among the warmest on record, and a strong event like this one is being watched closely for exactly that reason. The mechanism is, at its root, simple bookkeeping of heat. During La Niña, the cool phase, the Pacific tends to soak up and bury heat, which holds the planet's average temperature down a little. During El Niño, the ocean gives that heat back to the air. A vast stretch of the tropical Pacific runs warm, and warming that much ocean warms the air above it, which mixes into the global average. The planet does not gain heat from nowhere. The ocean simply shifts more of its stored heat to the surface where our thermometers sit. That bookkeeping showed up clearly in recent years. The cool phase that ran through last year and into early this one helped hold global temperatures down a touch, which is part of why the most recent year, while still very warm, ranked a step below the couple of years before it. Those prior years had carried El Niño warmth or its aftermath. Now the dial is turning back the other way. With El Niño in place and strengthening, the planet loses that cooling hand on the scale and the warm push returns. There is an important wrinkle in the timing, and it keeps the forecast honest. El Niño's biggest effect on global temperature usually does not arrive while the event peaks. It tends to come in the months after the peak, with a lag. The ocean warms, the air follows, and the full warmth works its way into the global average over the following seasons. So even though this event is expected to peak in the coming winter, its strongest push on worldwide temperature may land later, stretching into the following year. The heat outlives the peak. This matters because of the ground it lands on. This El Niño arrives on top of a world that is already running warm from the long-term rise in global temperatures. The El Niño push and that background warmth stack. One is a temporary swing that will reverse when the event fades. The other is a steady climb that does not. When a strong El Niño adds its temporary warmth to an already elevated baseline, the combination can drive the global average to new highs, even though the El Niño part of it is borrowed and will be paid back when the cool phase returns. It is worth separating those two things plainly, because they are easily confused. El Niño does not cause long-term warming. It is a natural swing that has happened for as long as we have records, warming the planet for a year or two, and then handing that warmth back during the cool phase that follows. The long-term rise in global temperature is a separate, ongoing story. What El Niño does is ride on top of that story, adding a temporary bump that makes a warm year warmer still. The bump comes and goes. The baseline beneath it is what trends. For most people, this global signal is more a matter of understanding than of action. It will not be felt as a single hot day or a particular storm. It shows up in the yearly statistics, in where the coming year lands in the long record of global temperature, and in the background conditions that shape weather everywhere. It is the kind of effect scientists track in the averages rather than the kind anyone experiences directly. But it is real, and it is part of why a strong El Niño draws attention well beyond the regions it rains on. So this event reaches past any one country to touch the temperature of the whole planet, with its strongest push likely lagging into next year and stacking on an already warm world. That global warmth expresses itself unevenly across different regions, bringing heat and drought to some places and heavy rain to others. So the next piece is to look at how a strong El Niño's effects spread around the world, beyond American shores. Beyond American shores, a strong El Niño rearranges weather across much of the world, and the effects fall unevenly, helping some regions and hurting others. The same shift in tropical rainfall that bends North America's winter sends ripples through the seasons of South America, Africa, Asia, and the Pacific Islands. A global weather agency warned, as this event took shape, that a strong El Niño would likely worsen drought in some places and heavy rain in others, and raise the risk of heat waves on land and in the sea. The pattern's reach starts where it is born, in the tropics, and the rainfall map flips in fairly consistent ways. Because the heavy tropical storms shift eastward toward the warming central Pacific, the regions on the western side, around Indonesia and into parts of Southeast Asia and Australia, often turn drier, sometimes drought-prone, during El Niño. Meanwhile, parts of the normally drier eastern Pacific and the lands near it can see more rain than usual. The wet and dry zones of the tropics trade places, following the storms as they slide east. Those shifts carry real consequences for people, because so much of the world's farming leans on the timing of seasonal rains. A drier El Niño season can hurt harvests across parts of Southeast Asia, Southern Africa, and Australia, where the rains that crops depend on may falter or arrive thin. On the other side, parts of South America, especially along certain coasts and lowlands, can face heavy rain and flooding when the pattern steers extra moisture their way. Drought in one region and flood in another, both traced to the same warm Pacific, is the signature of a strong global El Niño. The heat side of the warning matters as much as the rain. A strong El Niño tends to raise the odds of heat waves in various parts of the world, on land and in the ocean both. The global warmth we discussed expresses itself locally as hotter spells in many regions, which can stress crops, water supplies, and human health. Marine heat waves, stretches of unusually hot ocean water, can harm coral reefs and fisheries far from the Pacific. So the felt effects abroad are not only about where it rains and where it does not, they include where it runs dangerously hot. It is essential, though, to carry the same honesty abroad that we held at home. These are tendencies, not certainties, and they vary from event to event. The agencies are careful to say that even a very strong El Niño does not deliver its expected effects everywhere. Some regions follow the textbook in a given event, and others do not, for reasons tied to their own local weather and to the unique imprint of each El Niño. The global map of likely effects is a guide to where the odds shift, not a forecast of what every region will get. This is why the world's weather and food agencies treat a strong El Niño advisory as a cue to prepare rather than to predict. Governments in drought-prone regions watch their water and their harvests more carefully. Aid groups position resources where the odds of failed rains or flooding rise. The advance notice that El Niño provides, sometimes seasons ahead, is genuinely useful for that kind of planning, because it gives officials time to brace for risks that have grown more likely. The value is in readiness, not in certainty. For the ordinary listener far from these regions, the global picture is mostly context, a reminder of how connected the planet's weather really is. A warm patch of ocean near the equator can tilt the odds of a dry season in southern Africa, a flood in South America, and a heat wave in Asia, all at once, all from the same source. That connectedness is the deep lesson of El Niño. The Earth's weather is one linked system, and a strong push in the tropical Pacific is felt in some measure nearly everywhere. So the event's reach is global, helping and harming different regions in the same season, with the steady caution that the map shows shifted odds rather than fixed outcomes. That caution has run through this whole report, and it deserves to be faced directly rather than tucked into the edges. So the next piece steps back to look honestly at what we do not know, and at why even strong odds are never promises. This whole report has leaned on a single phrase, repeated quietly through every section. Tendencies, not promises. It is time to face that honestly, and put the uncertainty at the centre, because understanding what we do not know is as important as understanding what we do. A strong El Niño tilts the odds. It does not script the season. Start with the heart of it, stated by the people who issue these forecasts. Even a very strong El Niño does not bring its expected effects everywhere. A bigger event tilts the odds harder toward the typical outcomes, but the tilt is all it offers. Past strong events have left some regions behaving exactly as the pattern predicted, and others going their own way entirely. The strength of an event raises the chances that the textbook plays out. It never locks it in. Any single place can be the exception. Layer on top of that the variety among events of similar size. The director of the Weather Service made the point plainly when this one was declared. Every El Niño is unique, with its own imprint on the weather. The strong winters of the past did not deliver the same weather to the same places. Their peaks came at different times. Their heaviest rain and worst drought landed in different spots. So even knowing this event may reach the top tier, we cannot simply copy an old strong winter onto this one and call it a forecast. This El Niño will write its own version. Then there is the genuine split in the measurements themselves, which we walked through earlier. By the raw ocean number, this event reaches toward record heat. By the relative measure that strips out the broad warming of the tropics, it looks strong but more moderate, and the atmosphere may follow the calmer reading. That gap is not a flaw to hide. It is an honest uncertainty about how much punch the event will carry into our skies. The ocean may set records while the felt El Niño behaves like a solid, ordinary strong one. Reasonable scientists hold both possibilities at once. The forecast for strength is itself a range, not a single fated outcome. The headline figure put the chance of a very strong peak at a little under 2 in 3. That is a real lean toward the high end, and also a real chance, better than 1 in 3, that the event tops out a notch lower. Forecasters give a probability rather than a flat call precisely because the ocean still has months to evolve and could land across a spread. Honesty means reporting the lean and the spread together, not collapsing the odds into a certainty they were never meant to be. There is even uncertainty in what comes after. The current outlook suggests this El Niño should peak in the coming winter and then fade, with the Pacific expected to swing back toward the cool phase, La Niña, sometime next year. That is the favoured path, but it is a forecast about a season more than a year out, and such long-range calls carry wide error. The event could fade faster or slower than expected. The swing that follows could be sharp or mild. The further ahead the forecast reaches, the looser it necessarily becomes. None of this uncertainty is a reason to dismiss the forecast. That is the balance worth striking. Uncertainty is not the same as ignorance. We know a strong El Niño is in place. We know roughly which way it tilts the odds across the country and the world. We know when its effects are likely to peak. What we do not know is exactly how strong it will get, exactly which places will follow the pattern, and exactly how hard each effect will land. Holding both the knowledge and its limits at once is what an honest forecast asks of us. So the right posture toward this event is steady attention, rather than either alarm or dismissal. Respect the odds, watch how they firm up, and keep in mind that any single outcome can surprise. With the uncertainty laid out plainly, the practical question follows naturally. Given what we know and what we do not, what should a person actually watch for in the months ahead, and what simple steps make sense? That is the next piece to take up. Given everything laid out so far, what should a person actually do, and what is worth watching in the months ahead? The honest answer is calm and modest. There is little to do today, in the quiet of summer, and a few sensible things to keep an eye on as the season turns toward winter. The right posture is steady attention, not worry. Start with the watching, because that is most of it. The agencies update the status of El Niño once a month, on the second Thursday, in the same kind of report that declared it in June. Each update refreshes the ocean readings, the strength of the event, and the outlook for the seasons ahead. Following those monthly updates is the simplest way to track how this event is firming up, whether the very strong odds rise or ease, and how the winter outlook sharpens as fall approaches. They are public, plain-spoken, and meant for exactly this purpose. Alongside those, the seasonal outlooks are the practical guide for your own region. As fall arrives, forecasters put out maps of how the coming winter is likely to lean, wetter or drier, milder or cooler, across the country. Those are the documents that turn the broad El Niño pattern into something local. If you live in the wet-favoured south, they will tell you how strongly the wet lean is expected. If you live in the milder north, they will sketch the warmth. Checking your own region's winter outlook in the fall is the single most useful step for planning. The concrete preparations are the ordinary ones, matched to where you live, and none of them are unique to El Niño. In flood-prone parts of the south and the west coast, the standard steps apply. Know whether your home sits in a floodplain or below a slope that could slide. Clear gutters and drains before the rainy season. Keep an eye on local forecasts when several storms line up, and heed official warnings during big ones. These are the same things that make any wet winter safer, done a little ahead of time. In the drier favoured regions, the northern interior and the Ohio and Tennessee valleys, the watching is more seasonal and less urgent. There is rarely a single storm to brace for. Instead, where water is tight, it is worth following how the winter's snow and rain accumulate, since a dry season can pinch water supplies into the following year. For most households there, a drier, milder winter asks little in the moment. The attention that matters is the slow kind, tracking the season as a whole. Along the hurricane coasts, the guidance holds steady regardless of the quiet Atlantic forecast. Prepare for the season as you would any year. Keep your supplies, know your evacuation route, and watch the short-range forecasts when a storm appears, because the seasonal outlook cannot tell you whether your particular coast will be the one in a storm's path. A below-average season still takes only one landfall to matter. In Hawaii and the desert southwest, where the Pacific side runs more active, the same calm readiness applies through summer and fall. Underneath all of these specifics sits one general habit, and it is the most valuable of all. Lean on official sources, the national weather agencies and your local forecasters, rather than on alarm. The El Niño story attracts dramatic language, superstorms and historic winters, and some of that overstates what the evidence supports. The agencies issue measured, regularly updated guidance precisely so that people can plan without panic. Trusting that steady stream of information and acting on it in ordinary ways is the whole of what most people need. So the practical takeaway is light. Watch the monthly updates and your region's fall outlook, do the ordinary seasonal preparations that fit where you live, and lean on official guidance over hype. That readiness is enough to meet whatever winter this event brings. With the watching and the doing laid out, only one thing remains, which is to draw the whole story together. So the final piece returns to where the event stands now, what is settled, what is still open, and what comes next. So where does this leave us? With the summer quiet outside and a strong pattern, building unseen in the Pacific. It is worth drawing the whole story back to a single steady picture before we close. On the 11th of June 2026, forecasters confirmed that El Niño had arrived, the first time the warm phase had been in place in about 2 years. That much is settled. The ocean crossed the line, the air above it responded, and the advisory went out. What else is firm is the strength so far and the lean ahead. The ocean has warmed quickly, running near record warmth for the season by the middle of June, with a large pool of heat stored beneath the surface to feed it forward. The forecast carries a better than even chance, a little under 2 in 3, that the event reaches the very strong level by the heart of winter, the highest category there is. That early speed and that high lean are what lift this El Niño out of the ordinary and earn it a closer look. The Pacific picked the warm side again, and it did so with force. What is known about its likely effects forms a coherent map, even if the details stay uncertain. As winter comes, the jet stream is favoured to slide south, steering storms across the southern tier. The south leans wetter and a touch cooler, with relief and flood risk riding the same storms. The northern interior leans drier, and the north and Alaska lean milder. The west coast, California most of all, faces the heaviest version of the water story, drought relief and flood risk braided together. The Atlantic hurricane season leans quiet, while the eastern Pacific leans active, and the whole planet gets a temporary warm push, likely strongest after the event peaks. What remains open is just as important to say plainly. We do not know exactly how strong this El Niño will get, only that the odds lean high. We do not know which regions will follow the pattern and which will defy it, because every event carries its own imprint and even strong ones do not deliver their effects everywhere. We do not know precisely how hard each effect will land. The two yardsticks still disagree, with the raw ocean reaching toward records while the relative measure suggests something more moderate. The honest forecast holds the lean and the doubt together. There is also the matter of what comes after, which is itself a forecast worth holding loosely. The favoured path has this El Niño peaking in the coming winter and then fading, with the Pacific expected to swing back toward the cool phase, La Niña, sometime next year. The wheel keeps turning. The warm phase that just arrived is not a permanent state, but one stretch of a long rhythm that has rocked back and forth for as long as we have watched it. This event will build, peak and ease, and the Pacific will move on to its next setting in time. The next thing to watch is clear and close at hand. The monthly updates through the summer and fall will show whether the very strong odds rise or settle, and the seasonal outlooks issued as fall arrives will turn this broad pattern into a forecast for your own corner of the country. Those are the documents to follow as the quiet of summer gives way to the season when El Niño finally makes itself felt. The story moves from the ocean to the sky to the ground over the coming months, and those updates will track it the whole way. For now, the sensible response is the calm one. A strong El Niño is in place. Its grip on America is real, unusual in its early strength, and still mostly ahead of us, waiting for winter to tighten it. There is nothing to fear in the summer air today and much to watch as the year turns. Keep an eye on the steady official updates, do the ordinary preparations that fit where you live, and let the season unfold. We will be here to follow it with you, calmly, as the next chapter of this one writes itself.